Hello friends, my name is Atul Dwivedi, and in my group there are three members, myself, Kanaiya and Pranav. And today we are going to talk about big data project beta version. So there are some topics which I am going to cover in my big data beta version, like what is all about what is my data and how I am going to download the raw data and how I am going to convert data into CSV format, and then how going to create batch views for the filtering of data, and then how I'm going to integrate the batch views into serving layer, and then how I'm going to create tables in SQLite and executing the queries, and what is my output after performing the queries. So these are the points which I'm going to cover. So raw data. Basically, my data set is all about Wikipedia. It's a complete copy of all Wikimedia wikis, and it is in the form of XML. And the total size of my dataset is 250 GB, and if I and my data is separated in month wise, like in 1 month contains 50 GB of data, so we have 5 months of data. So data format. As you can see in the in this slide, there are many fields available in my data format. Approximately 17 fields are there, and I'm not gonna consider all of the fields. Which fields are necessary for me? Those fields I'm going to consider. But as you can see in there is a title field, and there is a ID, and there is a timestamp which is the contributor contributed in the dataset, and there is a bytes, as you can see below here, and these are it is the total number of bytes which has been taken from the server for particular page, which is this page. So these are the sum of those bytes. So how I have downloaded the data in my local directory, which is available on cloud. So as I previously told you that my data is in the form of month wise, and we have 5 months data, and 1 month data is 11 GB when it is compressed, and after compressing the data it contains 50 GB for 1 month. So that's why our whole size of data is 250 GB. And we have used wget command for downloading the data into our local directory, and for unzipping our downloaded data we have used bzip2 command, because our data is available compressed in uh, bzip format, and we have downloaded and unzipped 5 XML files of 50 GB each. So as you can see in the command line that we have five separate months data. And now how we are filtering the data. So as I have told you previously that in our data there are 70 fields, but we are not going to concentrate on all of the fields. Which fields are necessary for us, on only on those fields we are going to concentrate. And so firstly we'll filter our data, and then after filtering the data we'll save the filter data into CSV format. So and so you can see this is the output of my data, and rest of the thing will be explained by my group members.
Hello friends, my name is Kariya, and previously Atul explained you about the data which we are going to use for a big data project. and how we are downloading it to our local folder. So moving forward to the next thing, which is converting the data into CSV format. So as you know that data is in XML format, which is zipped in bzip2. So we are unzipping the format using bzip2 command. And for that XML file, we have our data in between the pages, page and slash page. So we are extracting all those data and storing it in CSV file. There are around 14 to 15 fields, around 17 fields, and we are using only 9 fields out of that. So how we are doing that actually? For that, we are using one Hive XML survey, which I'll show you in the coming sessions. So this is the uh, s- shell file which I have created. So as you can see, I have here bzip2. I am using the command for this 5 files so that it will be unzipped. And this you can see hive minus f parse data.hql. This is my HQL script which I have written. And this file, I'll show you how exactly Hive is extracting this data and storing it in table. So let's first start with that Hive script. In this, I'm adding first this Hive XML serialization deserialization UDF. As you can see in comments, adding UDF to parse XML file and using this format, input format and output format from this serialization deserialization UDF. I'm storing whatever that means 9 fields from this XML file, which is stored as title, NS, ID, revision parent ID, timestamp. Timestamp is in UTC format. I'll show you how it is displaying. Username, user ID, and bytes. So this is how we are creating the table in Hive till here, till row number 23, and then all the files, all 5 files which we have downloaded earlier, we have to load the data from those files into the wiki table, wiki data table which we have created. So this is the command for that: local load data, local input into Wikidata. So it will take time to load the data, but once data is loaded, what we'll do is we'll store the data which is stored in that table in an output file. This is how we are going to store the file inside override, and this is the path I have given to store that file, and the file will get stored in part files. So when we stored, it was around 1026 files. It depends on the reducer, how many reducers are assigned to the task. Depends on that, files will be generated. So this will be the folder data filter data underscore files. This is a path, and this will files will be the folder in which all the files will be there. So once files are stored, the next thing I want to do is I have to merge those files. So you can see that in this shell script I have given the command like first I'm copying the files and folders to local because those were stored to sorry, I'm copying the files to cluster, Hadoop cluster. So to create the backup for that. And now I need its merged file because those are so many files. So better to create it in one file. So I'm using this Hadoop fs get merge command, and the merged file will be stored on home directory in the home directory as merged underscore file.csv. This file is the extracted file, filtered file, which we need for further processing. And for this also, I have copied the same file to cluster so that to keep it on home as well as on cluster. So this is the last line is the command for that. Now moving forward, this shell file can be executed as bash minus x parse underscore data dot sh. Now creating batch views for filter data using pick. Now as we have created the CSV file, now next thing is giving we are giving this input to pick. will be generating batch views using pig. So in this CSV file, we had around 8 crore records, 8 crore records. So we are generating total of 3 batch views. First one will be distinct user ID and bytes contributed by the user and total number of contributions, which means one particular user, how many bytes he has contributed and number of pages he has contributed. So it will store user ID wise. Second thing is according to the titles, we have different titles. So for one particular title means one particular title, how many times that particular title or that page was revised and how many bytes was consumed by that particular page. So this can be helpful for means what are the frequent revisions for which is trending in that particular month. We can find that. So this view can be useful for that. And page counts year wise. We have data for different years files which belongs to different years. So we are generating year wise count for that. So how we are doing that? This is the pick script. For getting year, I'm registering that Joda time 2.4 dot dot. This is again one more UDF where we get time functions, date functions. So I can use get year functions directly. I can use it. So the very first thing, I'm loading the data in Wiki. Wiki is my relation where I'm storing all the records from the merged file. Then I'm grouping file by user ID as we are generating user ID views. So then I'm filtering to ignore the null values because few of the fields are null like user ID are blank or some wiki bytes are not given because it may not be contributed. Some other fields are contributed. So we are filtering that out and then storing the output file and as output one. Similarly, we are generating second batch view and third batch view. Only the thing is, as I discussed previously, these will be the views and these are the pig scripts for that. Even for this, we have included the execution of pig in our shell file. So the name of this file is wiki underscore project.pig and this can be executed by giving pig command, which will execute on MapReduce mode by default. Total shell file, you can see that, yeah. If you see, now once data is done, then we'll do pig project wiki underscore project.pig. It will generate the batch views at the desired path. Then what we will do is we'll get the merge file because again the output of this will be the input to our serving layer. That means SQLite. So what we'll do again, the output will be stored in part files. So I'm merging those files into one file. How I'm merging that? We have get merge command, and this is how we are going to merge home and with the name batch view one. So once we have created the three views, batch view one, batch view underscore two, batch view underscore three, this will be the input to our SQLite. But before that, I'd like to show you. I have stored everything, all the files, or on my local folder. So here, when we run that whole script at once, we are successfully able to generate batch view underscore one, batch view underscore two, and three, which was which is input to our SQLite, and all the scripts are present over here. You can see parse data.hql. This is the HQL script, shell script, and SQL script. So basically, by executing the shell file, it will call all these HQL and SQL and pig files. So, but if you need to run it independently, we have given the commands for the same, how those can be executed. If you happen to see the view of batch views we are creating, you can just have a look at that. See, as you can see, these are the titles first line. So the sorted way. So you can see these are for the very first column is title, then we have count, and then we have bytes for that. So basically on this we'll be running our queries. And here jar file I have XML I have given. Everything is given in the jar rar file which we are going to submit for this project. So that's it. And our next part, SQLite will be in serving layer. How this I just told you that input for serving layer. Now how the queries are going to come will be explained to you by our third group member Pranav Botti. Thank you. Hope you enjoyed the video.
Hello all, I'm Pranav. As part of our Wiki data project, I'm going to explain the rest of steps which after the data downloading, converting into CSV file, data ingestion, and then creating batch views for the data and also integrating, which all these aspects are covered and explained by my friends Atul and Kanaiya previously in previous video. Now I'm going to discuss about the serving layer, how we are going to create tables and do execute our queries in the serving layer. Okay, so now we got the batch views and we need to integrate them into the serving layer. For this, we are using SQLite. SQLite is uh, software or database where we can combine the individual results of different databases. We can store them. We can uh, execute ad hoc queries, and we can perform the similar queries to SQL. Now, so we are creating three tables through SQLite so that we can execute queries on this data. Here we are in our project we are creating three SQLite tables, that is three batch views. Three tables are created for batch views, which are we will be using. In the first table we have the user ID. Also the first field will be user ID. Second field will be the bytes, number of bytes that user has contributed, and the third will be the count, total sum of the bytes contributed. So coming to the second table, the second batch view, we are having the title of the wiki data, the revised wiki data, bytes, that is the bytes contributed to this wiki data, and also the count, total count of this wiki data. Coming to the third table or the third batch view, we have the year. We have filtered our data in the format of year so that we can get some time frame or time frame execution, time frame data given a particular time frame. We can query or get some data which we can retrieve in our result, and the count. So going on to our queries, firstly the sample queries which we are going to execute in this on this data is the first query being displaying user ID which contribute who I mean we do have wiki data, so the wiki data contains the contributors and their contribution bytes. So we are going to retrieve a user who has contributed the maximum number of bytes to the wiki data, and also a user who has contributed the minimum number of bytes. Here we are doing this in the form, I can explain you as, we are first initially selecting the grouping the data by user ID and then selecting minimum and maximum. I can run this and I can show you the query running is here. You can see the query I have copied, I have selected headers on. It shows that the table's headers, whatever the column name it has, it is displayed if we make the headers on option. And also coming to the mode column is displaying the results we have in the column format, that is each separated in different columns and making the results to be displayed or visualized in a good manner. So I'm going to run this now. Let's see, here in the SQLite I'm running this. Yeah, so we can see that the user ID 3 has contributed the minimum number of bytes 24, a total of 21 times. However, if we see the maximum, the contrast maximum is user ID 6 has contributed total number of bytes 378523965 with a count of 959 times he has contributed to the wiki data. So we have got our the first query result, that is minimum contributor and maximum contributor to the wiki data. Coming to the second query is displaying top 5 contributors in terms of count. That is, we have the Wikidata and the contributors. So we'll be selecting the top 5 whoever has contributed the most, the maximum. We are selecting them. So for this, we are going to do. I'm going to select. We have that data of the contributors in batch view, so I'm going to order it in the descending order and limiting it only to 5 contributors because our query is about only 5 contributors. We are going to limit it for 5, and also we are going to order it by the count with in a descending order. So the results of this query are here. You can see the top one being user ID 4 who has contributed for 7,588 times with the contribution bytes. You can see that, and also the contributor ID is 6 being the last fifth one being who has contributed with 959 times. Next, coming to the third query, we do have displaying titles of the Wikipedia page where revision history for the page is more than a given threshold. Like we are giving a threshold of like so particular number of times. If that has been revised, then we are going to display the titles of those wiki data. And for executing this, I do have the query. Here you can see selecting the title and also the count from where the given threshold we have selected it as 2000 because we do have lots of GB records. So we have selected 2000. So in order to get a good visualization of the results, here as you can see now, when we have selected the threshold to be 2000, there are 4 titles. The first one being one with the 5000 plus count, and the last one being list of some United States data, which is around 2800 times. Coming to our fourth query, the fourth query is displaying the bytes contributed to wiki data in a given time frame in terms of year. That is, previously as I have said, we are going to give a time frame that is so and so months or so and so years within this particular period between 2010 to 2020. What is the bytes contributed to the wiki data? And for doing this, we do have I'm going already we do have batch views for this too. So I'm going to give at the time frame specifying which year to which year, and I have selected as in between 2012 to 2016. We have done this for as a demo to give a better visualization. We have selected less time span, that is only the 4 years, but we can do much more. And here comes the result. The result is from 2013, 2014, 2015, these 3 years. We do have the data of number of times the wiki data has got contributed. That is our fourth. So we have the 4 queries done with one ad hoc query, and also coming to the final one, as we have displayed in our video that we have showed you how to execute all these step by step. Also we can do that. Here we have included everything in a file, in 2 files, so that just by running this you get our project, the results of our project. You'll get it visualized. You need not run each one step by step. And the two commands are bash -x, the parse data dot sh, where we are going to do all the data download, data filtering, data ingestion. And coming to the second one, bash -x project script, where we do have the batch views and also the table integration into serving layer and creation of tables in SQLite and running the queries. With these two commands we can run our project. And here, as I shown you in Hadoop, that our displayed results, this is an output or output screenshot. And for more information on our project, you can contact us, our group being Kanaiya, Kariya, Atul K Dwivedi, and myself, Pranav Botti, and our email IDs are also mentioned over here. For any more doubts, feel free to contact us. Thank you.